Well, good morning, you guys. Hopefully this is kind of audible. I have some background noise going on, somewhere between Barney and we have a pop machine back here. I'm actually hanging out in the school, and I'm with Ethan. He's got enough of a fever. He had a fever during school yesterday, and they kick you out for 24 hours. Plus, we all kind of feel funky anyway, so. But yeah, he's out sick from school, and we're hanging out, and hopefully, I saw some of you in the hallway. Ethan is having a blast coming through school and hanging out with the big kids. But anyhow, here are some things I wanted to go through. If you find your notes, in your notes, the ellipse section, I'm going to kind of go through ellipse and hyperbola, maybe a little bit of the parabola stuff. There's actually a video, if you look on the screen, or if we go back to my channel, there's a video about parabolas if you're interested. If you remember, I uploaded those videos to all the parabola stuff, so you can watch that tonight if you're reviewing for the test. So in addition to that, I want to add some additional ellipse and some hyperbola stuff just to get you back on track if you were off, or just a little extra recap before your test tomorrow. Your pretest is pretty comprehensive. You have those extra practice problems that I gave you yesterday. Those are tricky. They're just tougher ones. If you're looking for a challenge and you want to take a picture, send it to me and say, Mr. Seeley, I'm stuck here, or did I get this right? Hopefully, if I have some time today, I'll get a key for that as well. And then you also have today the term test review, part 1. This is just kind of a kickstarter, some problems. There's 33 problems that you can look at that'll get you ready for the final. There'll be a little bit more in the late part of this week, but this way you can work on that if you have nothing else going on. But let's go in your notes. If you see these 2 problems, if you have 2 points and it says, basically give me the ellipse and come up with all the information, its equation, etc. That's actually on the back of your pretest. We had problems like this. So I'm going to give you an idea of how that works. What you want to do is plot those 2 points and then just go from there. That's the biggest thing, is you've got to plot the points. So I'm going to do this somewhat rough-like, but if I go -2, -1, and plot that point, and I'm being pretty rough about it, and then 8, -1, and those are major axis endpoints. Major axis endpoints is a pretty good indicator that I found A in some regard. And if you want to look at it, since it's -2 and 8, that's just a span of 10 from one end to the other. And so, I can use red, that's fine. From here to here, we're talking about a span of 10. And you want to split that up, since the big thing we need to know is where's that center located? It's somewhere in the middle there, and it would be 5 in from the left and 5 in from the right to find that center, because everything we do graphing an ellipse has to do with finding that center point. So right now what I'm going to do is just you already know -2, -1, 8, -1, the endpoints. The center, if I go in 5 from the left or the right, this center is 3, -1. And that's kind of where everything kickstarts. And I just found out what A is, so you guys know that if I have this distance to the side here, A is the distance from center to an endpoint, and since that's got to be 5, since the whole span was 10. But those are the kind of things you want to deduce. If you're given a major axis endpoint, that's clues towards what A is. A is the distance from the center to one of those endpoints, and that's where I got my 5 from. Okay, so we're off to a good start. The next piece is you get some more information in there. It has major axis endpoints, and then you're given something about the minor axis that you can use. And then it says your minor axis has length 8. So, and it's off the screen on this one, so I can just write it off the side here. Minor axis is 8. And that gives you a distance, if you're going up and down, that's perpendicular to what we're doing right now. So 8 across on the minor axis from end to end. That means for me, that's going to be 4 up and 4 down from my current location to give me the minor axis. And so since this is -1, this is going up, and I'm not drawing this terribly well to scale. Maybe I should back off and try this. But if I'm at -1 at this location, then I'm going to go up 1, 2, 3, 4 up, put a point up there, and of course 4 down, so put it right about there. That's my minor axis distance. Not drawn to scale, so don't get into this as part of scale. Obviously, I'd make it wider than it is tall, and it's looking kind of the opposite right now. But your detail about the minor axis being 8 is a clue that B is 4. Okay, and it's all about A, B, and C on these conic sections. Those are the important dimensions. A, of course, is the distance to the major axis from the center, major vertice. B is the distance to the minor vertice, and C then is going to be our distance to the focal point along the same focal axis that A is on. So somewhere out here, we're going to have a focal point and another focal point, foci, we're doing plural, and the distance to that is going to be c, and we're going to get that from that relationship that is, be careful, it's a Pythagorean style relationship, but it's not the one that we're used to. It's a squared equals c squared plus b squared. And we can kind of tease that out another time, but we have a, so we're going to plug in what we do have, and we do have b, which is 4 squared, and we're just going to go about finding c squared in all our fancy pants ways that we can do. So for what I can see, we're going to take 25 minus 16, so we're going to get 9, so the c is actually, it's going to be 3. Okay, so that's a little bit of insight to this one. It means 3 over to get to my focal point, and so if I go from my local point next, let me back up. This point then that I drew is a little bit off of that focal point. And this one's a little bit off, not that I expected it to be good. But that focal point, since it's 3 to the left from my center, it actually fell right on the axis there. And since c is 3 to the right from a center of over 3 up 1, this is going to be 6. Okay, so if you want the locations of those, here's my focal point. This one ended up at 0, -1. Okay, and this one ended up at, because that's 3 over from my center, 3, -1. And then the right one is 3 over, so it's 6, -1 is my other focal point. Okay. Now, you could go back now and list the coordinates to all the vertices, the focal points, etc., just by looking at the graph, and that's what I would expect. The only other thing we need is the equation that goes with it. So once you have the drawing, then you can just reference all the other things. You can always have a sketch on the test. If you just label the coordinates of things in the graph itself, that's perfectly fine, as long as you know what you're referencing. But the equation, it's an ellipse, so you're dealing with some x minus your x coordinate at the center, and ours is 3 squared, and then we're going to have a plus sign, and then we're going to do a y minus your y coordinate. This is all equal to 1. I'm going to do it on the left today because I'm running out of room. But y minus a -1, so it's going to be y plus 1 in the end. And then underneath each of these, you're going to put a squared or b squared. And in an ellipse, a squared is going to go under the axis that it's parallel to. It's parallel to the x-axis, the long axis, contrary to my drawing, looking kind of all lopsided vertically, but it's left and right is definitely a wider distance. So we're going to put our a squared, our 5 squared, underneath x, and we're going to put our b squared, which is 4 squared, underneath our y. Okay, that's the end of the equation. That's good enough, and you can move on from there. That's like the back page of your pretest. It gives you 2 points, and you got to come up with all the equations that go with it. So that's the end of the story on that one. Now I'm going to go, we have the same question actually, but for a hyperbola, and we can use these same 2 points, but say, hey, what's the equation of the hyperbola? And we can go